Question says, use expansion by cofactors to find the determinant of a matrix. You have a 3 by 3 matrix, everybody. Remember the expansion with respect to a row and a column. So if you decide to use the ith row expansion, this is the formula that you're following. Your J is changing, your I is fixed. But if you decide to expand with respect to a column, your I is changing. So take a look. Suppose we want to expand along the second row. Why? Because it has a 0. Remember that. You either select a row or select a column. It doesn't matter. But our goal is to have as many zeros as we want, so we can eventually make computation easier. This row has 0 as its entry. So I'm going to use this row. You might say, hey, why we are not using the third column? Absolutely fine. We can do that as well. Let's do the computation for cofactor for the second row and the first column. This is equal to -1 to power 2 plus 1, which is 3 times minor for the second row and the first column. The minor for the second row and the first column can be calculated by deleting the second row and the first column. You end up with this 2 by 2 matrix. Now, what is the cofactor for the second row and the second column? It is equal to -1 to power 2 plus 2, which is 4, times the minor for the second row and the second column. The minor for the second row and second column can be calculated by deleting the second row and the second column. Finally, the cofactor for the second row and the third column is equal to -1 to power 2 plus 3, which is 5, times the minor for the second row and third column. So how do we calculate the minor for the second row and third column? You have the second row deleted and the third column deleted. Take a look. The determinant of the matrix can be written as the entry on the second row, first column, times the cofactor on the second row, first column, plus the entry on the second row, second column, multiplied by its cofactor. Finally, you add the multiplication between the entry on the second row, third column, by the cofactor related to the second row, third column. But take a look. The determinant of this matrix is equal to -3 times the determinant of this 2 by 2 matrix that you already know where it comes from. This is M of 2 and 1, 4, -2, 4 and 3, plus. So this is just highlighting what is A sub 2 and 1, plus 2 times the determinant of the matrix that you calculated here, M sub 2 and 2, which is your minor by deleting the second row and the second column. Note that your second entry is A sub 2 and 2, which is 2. So you're going to copy that guy over there. And please remember the cofactor is -1 to power 4. So you don't lose anything here. You get the exact same positive number as you saw before. And finally, here, we're going to multiply 0 by the determinant. You have 0 as the third entry, which is A sub 2 and 3. You copy down 0, multiplied by that determinant. So you basically get -3 times 12 plus 8, which is 20, plus 2 times the determinant, 3 minus 2, which is 1. And this is just 0. You don't even have to calculate this. And the determinant is equal to -58.